Welcome to the Introduction to Electrical and Computer Engineering at the University of Utah. I am Dr. Cynthia First, a professor of Electrical and Computer Engineering. Today we're going to be talking about units and scientific notation. We're going to review the units that we'll be using throughout this semester. We'll also review scientific notation and talk about converting between units and scientific notation. The reason this is important is because electrical engineers use very large and very small numbers all the time, meaning that we need several different types of units. I've chosen an example here of a company that's selling capacitors. You can see that they're giving the capacitance in picofarads. The voltage ratings are in volts and kilovolts. The tolerance is either in percent or picofarad, and the temperature coefficient and mounting type are used. So if you were searching for a capacitor today, these are the units that you would have used. We're going to use the International System of Units in this class, the SI units. You'll remember these, of course, from physics or from your previous experience. The units of length is meters, mass, kilograms, time, seconds, temperature, Kelvin. Voltage is a volt, and here's the symbol that we're going to be using for that. Current is given in amperes. Here's the symbol that we'll be using for current. Charge is coulombs. Resistance is ohms, and here's the symbol we'll be using for resistance. Capacitance is farads, and here's the symbol for capacitors. Inductance is henries. Power is watts. Frequency is hertz. I've also given you the relationship between the various SI units for our electrical components. When we talk about very large or very small numbers, we use special prefixes. You've seen these before. Prefixes that are very common in electrical engineering, for example, if we were talking about frequency of wireless communication units, would be gigahertz or megahertz, 10 to the 9 hertz or 10 to the 6. Kilovolts, for example, 10 to the 3rd, would be a large voltage. If we were talking about numbers that are very small, 10 to the minus 3 to 10 to the minus 18, for example, we would be using these prefixes. For example, capacitors are commonly sold in pico or nanofarad, or sometimes microfarad. We'll commonly find inductors in microhenries or millihenries. Milli is 10 to the minus 3rd, micro 10 to the minus 6, nano 10 to the minus 9th, and so on. There are several naming conventions that are used in our textbook and others. Current is given as I and voltage as V. Whether they're straight or italicized, these may or may not be time-varying. They're just general use letters. Time-varying constants, current and voltage, have this parentheses T, indicating that they are functions of time. They are not constant. Values that are constants are DC, or direct current. They are capitalized, I and V, shown here. Bold letters are in something special. In our book, these are typically matrices, vectors, phasors, Laplace, or Fourier transforms. When we want to convert from units to scientific notation, what we do is we take the unit that we want, such as milli, and we just multiply the value by the number that goes with milli. So, for example, 1 millivolt is 1 times 10 to the minus 3 volt. 1 megavolt is 1 times 10 to the 6 volt. If we want to convert from scientific notation back to units, what we do is we take our scientific notation value, let's say 1 times 10 to the 6th, and then we divide by the value associated with the unit we want. Mega, for example, is 10 to the 6th, so we divide by 10 to the 6th. 1 times 10 to the 6th is going to give us 1 megavolt. Let's do this for millivolt. 1 times 10 to the minus 3 volt, divide it by the 10 to the minus 3, which is associated with the millivolt, and that's going to give us 1 millivolt. If we want to convert from one unit to another, let's say from millivolt to microvolt, sometimes you can just see how to do this. That's fine. But I'm also going to show you an easy way to do this, which is to match the units. We're going to use this throughout the semester periodically when we have calculations to do. Let's say, for example, we want to know how many microvolts are in 1 millivolt. So here's question mark, how many microvolts, and here's the 1 millivolt. Well, what we need to do is match units from this microvolt which we have to this millivolt that we want. So microvolt is 10 to the minus 6 volt. Are we there yet? Nope, we haven't gotten our millivolt taken care of. Let's say now we want to get rid of the volts and we want millivolts instead. So we're going to say 10 to the minus 3rd volt per millivolt. 1 millivolt is 10 to the minus 3rd volt. And then we're going to multiply this by 1 millivolt. Now look what would happen. We would be able to cancel out the volts we'd be able to cancel out the millivolts, and we'd be left just with microvolts. Hey, that's what we wanted. The math here would be 10 to the minus 6 on the bottom, 10 to the minus third on the top. That gives us a value of 10 to the minus third microvolts. 1 millivolt is indeed 10 to the third microvolts. Another way to do this is you can start with what you have. We have 1 millivolt and we want to know how many microvolts. So we take 1 millivolt. We know that a millivolt, 1 millivolt, is 10 to the minus third volt. So here's how we can convert millivolts to volts. Nope, that's not what we wanted. We wanted to get to microvolts. Now let's convert volts to microvolts. 1 microvolt is 10 to the minus 6 volts. Our volts would cancel out, our millivolts would cancel out, leaving us with 10 to the third microvolt. So in conclusion, we've reviewed the units that we'll be using, we've reviewed scientific notation, and we've talked about how to convert from one unit to another. Throughout this semester, I'm going to include a picture on each of our lectures of some of the beautiful places in the great state of Utah. This is Delicate Arch in Arches National Park near Kanab, Utah, clearly one of the signature pictures from the state of Utah.